Hi, in this video we are going to implement linked lists together, so let's get started. First of all, I'm going to create a distinct package with the name linked list, and I'm going to create several classes. We are going to have a node, as we have discussed in the theoretical section. A node is going to store the data itself as well as the reference to the next node. Of course, we will have the list interface, then we will have the linked list itself, and basically we will have an application.java from which we are going to test our application. I'm going to abbreviate it with app.java. So what about the node class? We would like to make it as generic as possible, so I'm going to use this t parameters with bounded types. So we would like to make sure that this t is going to extend the comparable interface, because we would like to compare items, whether it is a string, it is an integer, or is it a custom object. We would like to compare them. Okay, so first I'm going to have the data itself, so private t data, and of course we will have the reference to the next node. I'm going to call it next node. Okay. In the constructor, okay, I'm going to get rid of this. We will have the data itself. So I'm going to initialize the data to be equal to the data itself. And then I'm just going to generate the getters and setters for the data as well as for the next node. So generate getters and setters for the data and the next node. I'm going to override the toString method, and basically I'm just going to return this.data.toString. Hit Ctrl+Shift+F to auto format, and basically that's all about the node class. We have the data we would like to store, for example, integers or strings or custom objects whatsoever, and we have the pointer pointing to the next node in the linked list. Okay, what about the list interface? We would like to mimic basically how Java works. We usually have the list interface is going to define the operations we would like to implement in linked lists, and we can instantiate the linked list as a list interface. It's a good programming practice to program to an interface or a supertype. So that's why we are going to do it like this. Of course, this list is going to be generic because we would like to use it to custom objects, strings, integer, doubles, and whatsoever. And we will have several methods. The public void insert, for example. We have the data we would like to insert. Then we have the remove method. We would like to remove some data from the linked list. Then we have the public void traverse list method. And then we have, for example, the public void integer size. Okay. So, we have to make it to an interface instead of a class, and it's going to work fine. Just let's save it. Of course, we have to get rid of the void because it's going to return the size. So these are the methods that we are going to implement in the linked list, and these methods are going to define the concrete behavior for the linked list class. So basically that's all about this video. In the next one, we are going to implement the linked list class and the application class, and we are going to test that how to use our algorithm with custom objects. So it's very, very important that I'm going to use generics in this video with bounded type parameters and so on, because we would like to make it as generic as possible. I'm not sure whether you are familiar with the built-in data structures in Java, but it is generic too. You could use array lists for strings, for integers, for doubles, and for custom objects. And basically, this is what we are after. We would like to make a generic linked list where we can store whatever we want. So in the next video, we are going to implement linked list and the application. Thanks for watching.